Hello, can you hear me? Hello,
Hello?
yeah, can you hear me?
Yes.
Okay, we'll continue with our discussion.
Mhm.
Uh,
I
so
did a 2023 AMC 10B.
2023 AMC 10B.
Yeah.
Okay, just hold on, I'll get that. Okay, which problem?
First one I needed help on was problem 11.
Right. Problem 11. The Suzanne went to the bank, that one, right?
Yeah.
Okay. Suzanne went to the bank and withdrew $800. The teller gave her this amount using $20, $50, and $100 bills with at least one of each denomination. How many different collections of bills could she have received? So basically, there are $20 bills, $50 bills, and $100 bills, and one of each at least. And it should
Yeah.
add up to $800, right? So basically, we have to find the number of solutions of the equation 20a plus 50b plus 100c is equal to 800, right? Do you understand what I'm saying?
Yes.
A, B, C here have to be greater than equal to 1 at least.
Yeah, right.
And you have to find number of solutions of this equation.
Right.
Okay. So what you can do is you can already put 1 in each, right?
Right.
If
Yeah.
you already put 1 in each, actually you have already given 20, 50, and 100, right? Because
Right.
the problem has itself said that each bill at least one was given, right?
Right.
So, before we do that, actually, first we can simplify it a little bit by dividing by 10 and make the equation slightly easier. The equation can become this, and then we can give 1 in each. So that means 2, 5, and 10 has already been given. So that will be 17, right?
Right.
Your new equation would be we'll create new variables a dash, b dash, c dash. These can be greater than equal to 0. Okay. Do you understand what I'm saying right now?
Yes.
So the equation will become 2a dash plus 5b dash plus 10c dash is equal to, now it will not be 80, it will be 63, right?
Yeah.
Okay, fine. Okay, now basically this is a way of solution known as stars and bars method. So once we have done this, we want to give integers to each of these boxes, a dash, b dash, c dash, such that we can satisfy this whole situation. So the coefficients are there, which are 2a, 5b, and 10c. Let's think of what we can do to simplify that a little bit. If it was a simple equation like this, a dash plus b dash plus c dash is equal to something, then I would apply stars and bars method directly, and I will tell you how to do that. But before that, we need to simplify this equation a little bit because right now there are coefficients here, right?
Yeah.
So if you divide both the equation, both sides of the equations by, let's look at this equation. 2a plus 5b plus 10c is equal to 80,
Uh-huh.
and divide both sides of the equation by 5. You get 2a by 5 plus b plus 2c is equal to 16. That should immediately tell you that these are integers. So this has to be an integer. So a has to be some 5k, right?
Yeah.
Do you understand what I'm saying?
Yes.
So then the original equation can be written as 2 into some 5k plus 5b plus 10c is equal to 80, right?
Right.
So now you can cancel another 5 and you'll get 2k plus b plus 2c is equal to 16.
Yeah.
Correct?
Correct.
Okay, now divide by 2 here because that will give us k plus c plus b by 2 is equal to 8, right? Correct?
Right.
Again, k and c and 8 are integers, so b by 2 must be an integer. So b should be equal to some 2 times p, right?
Right.
Correct. So
Yeah.
now you would get k plus c plus p is equal to 8, right?
Right.
Where k, c, and p are integers. Correct.
Yes.
Now we have reduced the problem without it. Now there are no coefficients anywhere. K plus c plus p are integers, and all of this should be greater than equal to 1. K is greater than 1, c is greater than 1, p is greater than equal to 1. Because that was the initial condition on each of them, A, B, C, right?
Right.
Cannot think about it, K cannot be 0 because then A would be 0, right?
Yeah.
Similarly, P cannot be 0 because then B will be 0. right?
Yes.
So this is the point. K and C and P are all greater than equal to 1. So we can change the equation a little bit by already saying that 1 has been given in all of these boxes, right?
Yeah.
You are changing the variable and saying that instead of KCP, I will create new variables K dash, C dash, P dash. And I have already put 1 in all of them. So new variables start from 0 and it will be up to 5, right?
Right. Yeah.
Do you understand what I'm saying right now?
Yes. Yes.
All of these variables start from 0. It must add up to 5 because
Yeah.
we are saying that K was K dash plus 1 basically.
Yes.
Now can do stars and bars method here. And basically that method is that if you have an equation like this, x plus y plus z is equal to n, and all of them can be greater than equal to 0, right?
Yeah.
This is like putting n stars into three boxes. And how can we do that? We are going to put bars to separate the n stars. What do I mean by n stars? These are n identical objects,
Uh-huh.
right?
Yeah.
And these are three buckets in which I have to place them, right?
Yeah.
So if you put the n identical box objects or n stars in a straight line and just think about where can I put bars to demarcate which one goes into which box, right?
Yeah.
So notice that if you just put two bars, that is enough to separate it into three groups, right?
Correct.
Do you understand what I'm saying?
Yes.
If there are n identical boxes and you have three variables here, three buckets here, then two bars are enough, no?
Right.
Two bars are enough to distribute them into three different boxes, right?
Yeah.
So similarly, what you have here is five ones, right? Five ones. Or five is the number of stars. Three variables are there, so we need two bars, right?
Yeah.
So the way we find how many ways are here is you count the total number of stars and bars. So that
Uh-huh.
will be, let's say in this problem, it is 1, 2, 3, 4, 5, 6, 7 stars and 2 bars. So 9 stars and bars, right?
Yeah.
And out of these 9 spots, you have to decide which spots will be bars. So there are 2 spots for bars here. So, and
Right.
you have to decide where to put the bars. So 9C2, you have to choose where to put the 2 bars out of the 9 spots.
Right.
Do you understand what I'm saying?
Yes.
For example, if K dash plus C dash plus P dash plus P dash is equal to 5, I have 5 stars.
Uh-huh.
And because there are three variables, I need 3 minus 1 or 2 bars, right?
Right. Yes.
I can put them anywhere. For example, I can put them both bars like this here,
Mm-hmm.
which means that one box has 1, one box has nothing, and one box has 4.
Right. Yeah.
Or the bars could have been here or whatever, wherever you want, right? If the
Right.
bars were like this, then one box has 1, one box has 2, and one box has 2, right?
Right.
Do you understand what is happening?
Yes.
So basically, what we are doing is we are trying to find the number of solutions of this equation. And right now, notice that there are 5 stars and 2 bars. So the total 7 spots, out of which you have to choose where to put the 2 bars, right? 7C2.
Right. Yeah.
So 7C2 ways of solving this equation for all of them should be greater than equal to 0, right?
Right.
Remember earlier that equation was something like this actually. K plus E plus P is 8.
Yeah.
Because there all of them were greater than equal to 1 actually.
Right.
We already assigned 1 to each of the boxes and started calling the boxes as K dash, C dash, P dash now.
Yes.
Because now the situation is greater than equal to 0 for each variable, and then we can apply stars and bars method directly.
Oh, okay, yeah.
So 7C2 is equal to 21, and that will be the answer here.
Okay, yeah.
When we do counting and combinatorics, this is a very standard problem there. This is nothing difficult. It's pretty standard stuff. Okay.
Okay.
Did you understand what we have done?
Yes, I understood.
So first step was obviously to take the original equation and get some conditions on two of the variables. So we saw that A has to be 5K and similarly C has to be 2P, right?
Yes.
Because if you divide by some numbers, you should have integers everywhere, right?
Right.
After that, it was the second step, which involved the stars and bars method. If you
Yes.
search online also, you will get an explanation for stars and bars. You should find that out and do that research a little bit.
Okay. Yeah, yeah, yeah.
Okay, what is the next one?
The next one was problem number 17. Yeah, 17. Sorry, not
17.
17. Not 17, 16.
Okay. Uh, problem 16. Define an UPNO to be a positive integer of UPNO to be a positive integer of two or more digits where there up number. That's what he means. Up number to be a positive integer of two or more digits where the digits are strictly increasing, moving left to right. And define a down number to be a positive integer of two or more digits where digits are strictly decreasing, moving from left to right. Okay, so what is my up number? Positive integer of two or more digits. Digits are strictly increasing, moving from left to right. Left to right, increasing. And a down number is left to right, decreasing digits. And it has to be positive integer of two or more digits. Right?
Yeah.
Okay. For instance, 258 is an up number, 8620 is a down number. Let U equal the number of total number of up numbers and D is the total number of down numbers. U and D. We have to find out mod of U minus D.
Right.
Okay, fine. Uh, okay, digits are increasing from left to right for an up number. Now, okay, by the way, they have said that digits are strictly increasing, not just increasing. Strictly increasing means they are bigger than each other. If it was increasing, I would have said x greater than equal to y, but strictly increasing means x greater than y, right? Do you understand what I'm saying?
Yes.
Okay, so obviously, if you think about an up number, you have to start with something non-zero, right? Here, non-zero here, because the first digit on the left cannot be zero. And if it is non-zero, then you can never use zero, right?
Right.
Do you understand what I'm saying?
Yeah.
Because all the numbers after that have to be strictly increasing, right?
Right. Yes.
On the other hand, with a down number, you can have zero somewhere, right? Because the numbers have to decrease and zero can be used then, right?
Yeah. Right.
So the number of down numbers will be clearly more than the number of up numbers, right?
Yeah.
That is obvious. Uh, right. It has to have two or more digits. Two or more digits. Okay. Okay, so let's now try to count it. So if you think of up numbers, we can only use 1, 2, 3 till 9, right? And up numbers have to be two-digit numbers or they can be three-digit numbers, but they can maximum be nine-digit numbers.
Yes. Right.
Why? Because the numbers cannot repeat. Numbers cannot
Right.
repeat because they are strictly increasing. If it was just increasing, we could have repetitions, right?
Yeah.
So if they are strictly increasing, you can go from two-digit number, three-digit number up to nine-digit number. That's your options, right? So, so now think about how you would construct a two-digit number, which is an up number. First of all, you would select any two digits from these, right?
Right. Yeah.
That can be done in 9C two ways, right?
Yes.
Once you have selected any two numbers from here, you can obviously arrange them in the order so that they are increasing, right?
Right.
But that arrangement can be done in only one way, right?
Right. Yeah.
Because there is only one correct order. Given two digits, you can only arrange them in one correct order, right?
Yes.
Similarly, if you had selected three digits also, after that also there is only one way to create an up number.
Right.
Do you understand what I'm saying?
Yes. Yes.
So ultimately, creating a three-digit up number is basically simply selecting three digits, 9C three ways. Because after that, you can arrange them only in one way. Do you understand
Right.
what I'm saying?
Yes, I
If there
understand.
was no restriction for arranging in them in a certain way, we could have arranged three digits in 3 factorial or 6 ways.
Right. Yeah. Yeah. Yeah.
But now we have only one way, okay? So
Yes.
if you count the number of up numbers, you will do 9C2 plus 9C3 and so on till 9C9, right?
Yeah.
This is a two-digit up number. This is a 3-digit up number and so on. Correct?
Right.
This, by the way, is equal to uh, basically it is 2 power 9 minus the terms that are missing are 9C1 and 9C0. Because you should know that 9C0 plus 9C1 go on till 9C9 is equal to 2 power 9. Do you know this?
Yes.
Because this comes from binomial theorem, x plus y to the power 9 is equal to,
Yeah.
you can write all the terms and put x and y equal to 1.
Right. Yeah.
You will just end up getting this 9C0 plus 9C1 plus 9C9 is equal to 2 power 9. Correct?
Correct.
So basically, the number of up numbers are these, and 2 power 9 minus 9 minus 1, which is 10. So this is going to be 512 minus 10, so 502. Okay.
Right.
And now we have to count the number of down numbers. And now same method, except now you can use the digit 0 also, right?
Yes.
You have to, you can use the digit 0, but the first number will not be a 0, right?
Right. Yeah.
Basically, it's the same thing. You start off with some digits. After that, like let's say you put something, right? For the first digit. Uh, Actually, just take 10 digits now. You have 10 digits available. Take 10 digits and select 10C2, let's say. And after that, there's only one way to make it a down number, right?
Right.
It's literally the same thing, no, then.
Right. Yeah.
Do you understand what I'm saying?
Yes.
It's it's the same thing. 10C, there are 10 possible digits now because there are 10 digits available to us, right?
Right.
We could have 9-digit down numbers, but we could also put a 0 at the end and make a 10-digit down number in any case, right?
Right.
So this will be the same thing. It will be 2 part 10 minus 10C0 minus 10C1, right? So this becomes 1024 minus 10 minus 1. So 11. So 1013. And now you have to take the difference between up numbers and down numbers. And you can see that difference is 511. Do you understand what is happening?
Yes. Yeah.
Right. So, by the way, you should also remember that anytime you have an up number, you can flip it to get a down number.
Right.
So, 502 up numbers, you can immediately flip to get 502 down numbers, right?
Yes.
But we also have to consider the cases where extra numbers will come when you can put the extra digit 0 now, right?
Right.
Do you understand what I'm saying? That's why the number of down numbers is more, right?
Right. Yeah.
Okay. What is the next one?
The next one was problem 19.
Okay. Right. Sonia the frog chooses a point uniformly at random lying within the square 6, 0 to 6 to 0 to 6 and hops to the point. Okay. So there is a 6 cross 6 square. So Sonia chooses a point in the square randomly and hops there. Hops there. Then after that, she randomly chooses a distance uniformly at random from 0 to 1 and a direction uniformly at random from north, south, east, west. She now hops the distance in the chosen direction, and the distance is between 0 to 1. Distance is between 0 to 1, and the direction could be north, south, east, west. And she hops that distance. What is the probability that she lands outside the square? Right.
Yeah.
Okay. Hmm. And all her actions are independent. All of her choices are independent. What is the probability that she lands outside the square? All right. Uh, 1 second, let me think. So we don't know how much she will jump. That is unclear, but it will be something between 0 to 1 uniformly, right?
Right.
Like it could be anything. There is no preference of what value she will jump between 0 to 1. It could be any number between 0 to 1, right?
Yes.
So here we can use the concept of what is her average jump size, average value of jump, right?
Yeah.
Since each number has the same probability in this whole region, the average
Uh-huh.
value will simply be half, right?
Right. Yeah.
Do you understand?
Yes.
There is no preference for anything between 0 to 1. So average can be taken as the half of the smallest jump and the largest jump, the mean value, right? Now think about it. If this is the size of the jump, then you have to worry about the boundaries of this half region, right? Like a region which is half distant from the edges, right?
Yes.
Do you understand what I mean?
Yes.
If she's in any of these points, then only she can basically escape, right?
Right.
This distance is half, let's say, right? On all sides. If she is inside this portion, there is no chance she can jump out.
Right.
If her jump size was half, she cannot jump out from here, right?
Yeah.
So now what we will say is, let's analyze the condition that she ends up in these places when she initially chooses a point and hops there, right?
Yeah. Right.
Why have I marked the corners different? Because corners, there is a higher probability. No, actually,
Isn't it lower because it's farther?
one side she can jump here, one side she can jump here. And here, right, it is a higher probability of escaping from corners. Because there are two ways to jump out, right? But if you were here, you have only one way to jump out. Do you understand what I'm saying?
Yes.
So this is half, half. The area of this is half into half, right? Think of this corner. What is the area of this corner square? It is half into half, right?
Yes.
Area is 1 by 4. And the probability of escaping from here, if her jump size is half, if she had jumped in east, west or south, she would have escaped. So probability of escaping is half, right?
Yes.
The other two sides do not lead to escape.
Right.
Now, if you think of the whole area here, this whole area will be half and half are taken out. So it is 5 length and half width, right?
Right.
Area is 5 into half. And actually, you can just say 5 into half here also, 5 into half here also, 5 into half here also, right? Correct?
Correct.
So basically, area becomes 10. Area is 10 total, which is all of such regions, right?
Yeah.
Probability of escaping from there is only one way, the other ways don't work, right?
Right.
The probability of escaping, because there are 4 ways to jump. 1 by 4 is the probability, right? In this region. Correct?
Right. Yes.
So now what we have to figure out initially, what was the question? The question was, what is the probability that she lands outside the square, right?
Right.
So she can land outside the square in 2 ways. First, ending up in corners and then escaping, plus she can end up in these rectangles and then she escapes, right?
Yeah.
So either she ends up initially only she hops into one of these corners and then she escapes by hopping out, or she ends up in one of these rectangle areas and then she escapes, right?
Yes.
There are no other ways of escaping. And these two options are different options, and these are different options, so you have to add the relevant probabilities, right?
Right.
So what is the probability that initially she chooses a point such a way that she ends up in the corner squares, the 4 corner squares, right?
Right.
She could have chosen any point in the whole square. Corner square, if you see, has area of 1 by 4 only, right?
Right.
So total
Yes.
area of all the 4 corners is how much? 1.
One. Yeah.
And total area of the whole square was 36, right?
Yes.
So probability of ending up in a corner is 1 over 36, right?
Right. Yeah.
Any of the 4 corners, right?
Yes.
We are dividing by the area of our region by the area of the total square.
Correct.
Multiplied by probability of escaping from the corners is half.
Right. Yeah.
And similarly, now we'll add to that uh, one second. 1 over 36. Uh, so the other area would be 10 over 36 multiplied by the probability of escaping is 1 over 4, right?
Yes.
So what we would get here is 5 by 2 into 36. So we are getting 5 by 72 and 1 by 72, or 6 by 72, which is 1 over 12, right?
Right.
Do you understand what I'm doing?
Yes, yes, I understand.
So the main thing here is to decide what is the average value of the jump because that was not given, right?
Yes, correct.
The value of your jump is a random variable that can take any value between 0 to 1. The expected value of your jump will be half though, because there is no preference for any particular value. So you have to take the average value of the jump.
Right.
Are you understanding?
Yes.
So that is how you do this one. Uh, there probably will be other ways to do it also, but this is simple enough. Right. What is the next one?
The next one is problem number 20.
Okay. Um, right. The question is saying four congruent semicircles are drawn on the surface of a sphere with radius 2 as shown, creating a closed curve that divides the surface into two congruent regions. The length of the curve we have to find. Uh, Four congruent semicircles are drawn. Okay, the figure is a little unclear. What? 1 second. It should divide the sphere into two congruent regions. The four semicircles are creating a closed curve. Okay. Okay. Right now, the figure itself is not very clear for me. Uh, I don't know what he has drawn here. So this question is a little difficult because it is unclear what he has drawn. Something like this and another line, but how is it intersecting? Or is it intersecting? It shows like it is intersecting, right? Okay, let's skip this problem because I don't know about the figure only properly. I can't do much here. Do you understand what the problem is?
It's like, I don't know. It's like it's just asking like those semicircles, but I don't see four. I only see like two sort of with those curved lines.
Yeah, the figure is not very clear, but possibly it's like a baseball with those dotted lines and all, right?
Yeah.
But four are there. So maybe on the other side, which is hidden to us, there is two more, right? Something like that. But the problem that I have is how can it be a closed curve? What does he mean by that? That means there should be intersection between these, no, somehow.
Yes.
Intersection somehow and that divides the surface into two congruent regions. The closed curve divides the surface into two congruent regions. Let's skip this one for now. I don't know the orientation well enough to do anything. Let's go to some other problem which you have had issues with.
The next one was problem 21.
Okay. Each of 2023 bins is randomly placed into one of three bins. Which of the following is closest to the probability that each of them will contain an odd number of balls? Okay, right. There are 2023 balls, which are randomly placed into one of three bins. You have to put 2023 balls, and each of them has to have an odd number, right? What is the probability that each of the bins will contain odd number of balls? Okay. So if each of the bins has odd number of balls, the number of balls are at least one, right?
Yes.
None of the bins is empty for sure. Then you can put one of the balls in each of the bins already. From before only you can put one ball each, right? Already. Correct?
Yeah.
Because 111 has to be there at least. After that, 2020 balls are left, right?
Right.
Hmm. The 2020 balls are left after that. And every time now, when you try to put the balls in it, you should put pairs of balls. Why? Because that will make sure that the final number will be. Anytime you put any ball in a bin, you have to do it in pairs. So we'll make 1010 pairs. Okay.
Yeah.
So whenever you put it in pairs, you'll ensure that it's an odd number at the end, right? If I put one pair here or two pairs here, it will still be five or three, right?
Right.
Do you understand what I'm saying?
Yes.
So we can say variables are x, y, and z add up to 1010. Here 1010 are not balls, they are pairs of balls, right?
Yeah.
And each can have greater than equal to zero number of pairs now, right?
Right.
Do you understand what I'm saying?
Right. Yeah.
So now this can be done by stars and bars method, right? Because now we have greater than equal to zero condition coming, right? And these are
Yeah.
pairs of balls, not balls. So by stars and bars method, there are 1010 stars, three buckets. So we need two bars. It will be 1010 plus 2 C2. That will be the number of ways to do this.
Yes.
So 1012 C2 ways, right? Now, if you calculate this, uh, now obviously without any restriction, forget about any restrictions, right? This is the number of ways we can do it in such a way that every bin has odd balls, right? Odd balls in bins.
Right. Yeah.
That's what we did, no, by putting one and then doing pairs and all, right?
Yes.
But forget about oddness and all. without any restrictions, if I just put 2023 balls, right? Correct?
Correct.
To ensure that I will just do 2023 plus 2C2 in that case, right? By stars and bars method only.
Right.
Because there are 2023 stars and there are three bins, so you need two bars, right?
Right.
Do you understand what I'm saying?
Yes.
So 2025 see two ways to do that without any restrictions, right? And this is the number of ways to make sure that there are odd number of balls, right?
Right. Yes.
So the ratio of this over this should be the probability of getting odd number of balls, right?
Right.
We have to now find that and find the option that is closest to that. So 1012 C2 divided by 2025 C2. So this is going to be 1012 into 1011. N into n minus 1 by 2 is NC2. So like this divided by 2025 into 2024 by 2. So now this is going to be 2 can cancel 1012 into 1011 by 2024 into 2025. This is clearly 2, and now we are getting 1011 by 4050, right?
Yes.
Notice that it is close to 1 by 4, right?
Right.
If it was 4044, it will be exactly 1 by 4. Correct.
Correct.
So other options are quite far away from 1 by 4. If you see the other options, they are quite different. Do you understand what we are doing?
Yes. Yes, I understand.
So first we thought of, okay, how can we make sure that odd number of balls go? So already we know each ball, each bin has one. So we put that, and now we are left with 20 balls, which can be thought of to be in pairs of 1010 pairs. And now every time you'll assign a pair to a particular bin, right?
Right.
That ensures that always it will be odd number at the end, right?
Right.
So that gives us, by stars and bars, it gives us 1012 C2 ways to do it. Now, without any restrictions of odd even, the total number would have been 2025 C2.
Yeah.
And we are dividing them to get the required probability. Correct?
Correct.
Okay, which one was next?
The next one was 24.
Okay, they are asking us for perimeter of the boundary of the region consisting of all points which can be expressed by this 2u minus 3w comma v plus 4w, where u is between 0 to, all the variables are between 0 to 1. 2u minus 3w, v plus 4w. Perimeter of the boundary of the region. Okay. U, V, and W are all between 0 and 1. So technically, we need some way of finding out what kind of region this is. Region consists of all points which can be expressed as this. Okay. Basically, you will have to take lots of cases and roughly find all of the points that could come. No, if you take U and V and W as 0 and 1, extreme cases. The extreme cases should give you a rough idea of the kind of shape it will come. No?
Right.
So it will be the only way to do it that I can see is just try to find out all these points. No, when U and W are 0, when all of them are 0, you get a 0 comma 0, right?
Yes.
This point is there, 0 comma 0. How to get x negative? You can take this as 0 and this as 1. That will give us -1, the lowest negative value, right?
Yeah.
And v could also be 1, and then this would be 5, right?
Yes.
-1 comma 5 is a point here.
Right.
But v could have been 0 also. So it could have been up to here, 0 comma 5.
Right.
No, it would have been -1 comma 4, right? If
Yeah.
v was 0, u was 0, w was 1. U was 1, W was 1. In that case, you would get this point, this point. I mean, I think there is no other way. You just have to take all the possible cases and get all the possible points. Do you understand what I'm saying?
Yes.
There will be some possible points here, some possible points here. These are the extreme values of the points. Okay?
Yes.
UVW can take their extreme values of 0 or 1, and based on that, you will be able to find which points the region should be inside. Do you understand?
Yes. I understand.
After that, you have to draw, like, this is like a 3D, actually not 3D, 2D situation only. But you have to find the perimeter of that region. There are rectangles here, so it's not very difficult to find perimeter. But the point is that you have to take many cases to find all of these points. Once you have done that, after that, it is pretty easy to find the perimeter and stuff.
Yes.
So try this out. It's just about a little bit of casework and then some calculations you have to do. It's not a great question. It's annoying to do the casework like that. Do you understand?
Yes.
I can't think of anything more than that or anything smarter which will reduce the effort.
Oh, okay. Yeah.
You have to take cases, you have to find the points and then take perimeter, I think.
Okay.
Uh, the next papers that you should try are, you have tried 2024, right?
Mm-mm. You gave me 2022, 2023, and 2021.
Okay, so you can already try 2024 10A and 10B.
Okay.
2024 10A 10B. I will send you the document
Okay.
on WhatsApp for
Yeah.
the file. But that can be discussed next week, Thursday. The next class will be number theory. So we'll continue with that. But this week, try to do 2024, both of these papers. Okay.
Right. Yeah.
Okay. That's all for now then. I'll see you next time.
All right. Thank you.
Mm.
Bye.
Bye.